Perfect. All right, guys, I'm going to go ahead and get started. Going to do a little demo, talk about our latest product release. As a quick introduction, my name is Will Dillingham. I'm one of the product managers over at Inertial Labs. Our booth is right over here. But before I start talking about our latest LiDAR Payload product that has just been released, I want to give kind of a high-level introduction to Inertial Labs and have that kind of feed into some of the discussion points which makes our next generation LiDAR payload so exciting. So Inertial Labs' core competencies are with inertial measurement units and Kalman filtering. If you are familiar with Kalman filtering, it's the idea of taking in a multitude of various sensing components data and doing some sensor fusion there to get the best bang for the buck when it comes from a navigation performance perspective. So what we've done for our next generation payload is we've prioritized two things, and that is the ability to have it integrate tightly with a multitude of various platforms and the ability for it to be expandable in nature. So for the first one, integrations, I touched on our Kalman filter and the idea of taking in multiple sources of aiding data. We've all been there and we've seen all the different solutions that the LiDAR payload space has to offer. It's very few that you find a good LiDAR payload that can very easily hop from one system to the next from an application standpoint, mobile mapping, aerial, handheld. And one of the reasons that we have prioritized being able to do that well is because we don't think customers should have to buy a multitude of various payloads to do a very similar thing from hopping from platform to platform. In order to keep cost down, what we've done is we've taken some of the core competencies of our inertial navigation system and its ability to ingest aiding data, being external GNSS inputs, wheel speed or encoder data, external magnetic data, wind speed or airspeed inputs from a VTOL, a fixed wing, and push all of that into the Kalman filter to prioritize the best navigation system that you can get in real time and in post-processing, all as a means to have the best possible LiDAR point cloud that you can get for the price. The second thing that I've mentioned that we're kind of prioritizing with this next-gen system is expandability. We have redesigned our core component that goes inside of this next-generation payload, and we've added the ability to integrate up to 5 additional either Ethernet or USB-facing LiDARs, cameras, and control all of the time synchronization and logging directly to our payload. This is really convenient and nice, especially for the mobile mapping industry, where one LiDAR, especially of the mobile industry size and performance, people want an additional one to have a slightly different angle. In addition to that, they also want 360-degree field of view images. They don't want a single camera focused at a narrow field of view. They want to be able to capture the entire street view. Having the ability to time synchronize and log additional sensor inputs directly on this payload right here is going to give us the ability to control everything from data capture all the way to the deliverable inside of our software suite. This LiDAR payload right now is currently configured to support a couple of different hardware architectures. We've integrated it with the HESI XT32 M2X and also additionally the Ouster OS164 Rev 7. We've also integrated 2 cameras. The first one being the Sony ILX LR1. The second one is kind of a lower resolution, kind of for the mass market, simply to colorize point clouds, not necessarily for orthomosaic and photogrammetry work, but that is the Rebo R2 16mm camera. And that one really is kind of like the best bang for the buck. While if you want to do high-resolution ortho photogrammetric work, you'll end up selecting kind of this ILX LR1. Between those two LiDARs and those two cameras, we're able to sell to the international market as well as be fully NDAA compliant, and we think that's pretty convenient for a singular payload offering. I mentioned the ability to integrate with multiple platforms. We have partnered with Gremsy. If you guys are familiar with what they do, a lot of it is gimbals and kind of helping bridge the gap between various aerial platforms and the payloads that are mounted to those platforms. They have made for us a number of ports that are kind of these smart adapters. This means that the end users have the ability to procure one system, and then depending on what drone needs to be used for what particular mission of that particular week, the end user can simply remove 4 screws, swap out a Skyport for a FreeFly Astro or whatever mount that we've integrated in addition to these 3, and then swap it and put it into that drone and be able to do that mission. So that's kind of pretty much everything encompassing the next generation payload. We are located right over here in this booth. I can't remember our number actually, but that's okay because you can see us. But if you guys have any questions around this next generation system for all of its various applications, spanning from mobile mapping, aerial capture, handheld, I would be more than willing to answer any questions that you have. Guys, thank you so much for your time. Woo! Thank you. Got a question?
Yeah, so you're talking about being able to integrate previous or other LiDAR units.
Yes.
Will that include the ability to port in any Gen-I recipes?
Are you talking about their LiDARs in particular?
Just the whole sense is like, hey, I've got a whole other one of these.
Yeah, I see what you're saying.
Can I port it over in a different mount?
So currently, no. And that's simply, I guess I'm still a little confused about the question. So the Gen-I system is a fully integrated payload.
Use that as the main sensor, but instead of using that as one of the 4 sensors, you just use a Gen-I.
Aha. Unfortunately, no, and that is because simply the Gen-I solution only has 2 Ethernet ports. One's for the LiDAR, one's for the internal logging. There's no additional interface that has been built in to send that data anywhere else. That's a great question.
Is this going to be compatible with like the ODK on DJI?
Yes, that's a great question and something I did not touch on. So the motherboard that was redesigned for the Gen-II system, we are currently building into our development roadmap the direct support of DJI's Payload SDK, as well as we're going to be running MAV proxy and MAV link so that you can communicate with that drone in real time. Not just power, but also data. Another thing that I did not touch on that I think is important to mention is for RTK missions. You know, the controller and the drone already has a fantastic radio, ideally, if the drone manufacturer is doing their job right. We want to leverage that and be able to then receive those RTCM corrections directly from the drone and send that down to our payload. So that's an interface that we already have built into this, and hence the multiple rows of dense header pins on these smart adapters that we have. It was a great question. SLAM, yes. Another thing that I did not touch on, thank you, David. This next generation system, we've gone from a IMX6 Verisite motherboard to a Spear MX8. This computer has 2 high-performance ARM A72 core processors running at 1.6 gigahertz, and another 4 A54 processors running at 1.2. And 8 gigs of internal DDR4 RAM. So this gives us the ability to now do in real-time SLAM processing on-side, on-board this next generation system. So not just a post-process application, but also for real-time developers to be able to take this stack, put it into their system, and utilize it for real-time SLAM development. Great question. Any other questions? No? All right. Thank you so much. Thank you for the opportunity, guys. Thank you. Woo. Thank you so much.